I hope it will be recorded because the previous class was not recorded. Now, okay, dear students, then we start, and we need to speak today about logic gates, a little bit of principles, how processor works, and we can also have a look into flip-flops, and this will be the main tasks for today. Here I have given you some of the links. You can see the CPU simulator, arithmetical logical unit, bit locker adder, and the logic gate simulator. So we are going to work with them. So, but first of all, we will work with the logic gate simulator. I will explain you some basic things here, and then we will try to understand how processor works. So basically how main processor works, how it can compute two numbers together, so how it can add two numbers, and you will see that actually it is only the special kind of transistors which are put together there. So first of all, let us play a little bit with logic gate simulator, and I will explain you what is a logic gate. You know what is a logic gate? So here we can have, let us open this logic gate simulator like that. And you can see also this way you have the link, yeah, so in the Moodle, so you can open this like that. And here you can see the special kind of tool which we have online, and we can work with logic gate simulator. So let us try to understand the basic different things with the logic gates here. And do you know what a logic gate? Just a question to you.
It's like a check where we can put so logic gate, we can have inputs and like some kind of
output, if statement, yeah. So we can have something like that. I can launch my notepad as well. So I will try to explain you what is the logic gate in this case, and then we can watch it how it works. So you see, we can have input. We can have like 1 and 0, and we can have the operator AND. You know, the result is then we can have like that. So here we have 1 and 0 as the entry parameters, but we have to unite them. And if you put AND, how do you think what will be in the result, 0 or 1? If we have 1 and 0 before, so we apply AND logic gate, what we receive in the end? We can try to figure out. Maybe 0. Why?
Because AND means multiply.
Yeah, AND means that you have to have both of them equal. So we need to have both of them zeros or both of them ones. And then you have either 0 or 1. But if you have, you can say, for example, 1 stands for true and 0 stands for false. And then here we will have 0, which is also false. Do you know that true or false, these are Boolean expressions, yeah? And then we can have some kind of logical tables. For example, we can say like A, B, and A and B. So we can create a special logical table for this. I can show you how to do that. So here we can have the following. We can create the table, and here we can have, for example, we can have A0, B can be 0, then A can be 0, B can be 1, A can be 1, B can be 0, and A can be 1, and B can be 1. So these basically are 4 different options which we can have, and then we unite them together. We can have the result as the following. If this one is false and this one is false, then the result is also false, so it is 0. Yeah. If this one and this one is like that, this one is false, this one is true. If we unite them together using AND, the result will be, so it should be both of them. So false and false. This here is 0 and 1, but if you unite them, then it will be 0, because it is like, it doesn't hold true. one is false, one is true, then it's not true. Yes, so and here this one is true, this one is false, then the result is false again because it is, yeah, but here this one is true, this one is true, then finally we get one. So this is, and it means that we have basically logic gate. Now I can show you how this can be represented in electronics. So we have toggle switch. So toggle switch means that we can switch it on, switch it off. If we switch it off, there is no electricity. If we switch it on, there is a current. So, but now we can see we have AND gate. Yeah. So we can connect it like this, and we can have output as a lamp, and we can join it like this. So you can see now there is no current, there is no current, lamp doesn't shine. If I switch one switch, so it gives me true, so there is a current, but this current doesn't go. So AND statement will not allow the current to go through, so the lamp will not switch. If I switch this off, switch this on, the same happens. But if I switch both of them, the lamp starts shining, because this gate allows the current to go further only if it receives two currents. Do you understand it? So this is the special current which is called AND. Yeah. Please open in the Moodle, open this link, and try to play with this. So you can also do that. Yeah. So try to play with this.
If the both conditions will be true.
So this is AND gate, this is OR gate, this is XOR gate, and in the AND gate you have to activate both of the currents in order to make lamp shine. In OR gate, it is enough to activate at least one, and it will shine also when both are activated. But in XOR gate, it's enough to activate one, but it will not shine when both are activated because it is exclusive OR. Yeah, so you need to understand that. And now the question is, why do we need logical gates? How do you think? Why do we need them? Yes, so let us now try to see how two numbers are being added together, and we will understand why we need those logical gates inside the processor. So imagine we have two numbers like 2 plus 3. Yeah, how much is 2 plus 3? It is 5. Yes. Now let us try to see how we can put them together in binary format. What do we have to do? It is how much is 2 in binary format?
0, 1.
0, 1. I will write 0, 0, 0, no, 0, 1, 0. This is like that, yeah? This is 2. In 3 bits. If I put some 3 bits, it's like 0, 1, 0. Do you agree?
Yes.
Yeah, okay. Then how much is 3?
How much is 3?
Yes.
1, 1, 0.
I think it's 0, 1, 1.
Yeah.
It's 0, 1, 1. And now if I want to add it, how much is 5?
How much is 5? 1, 0, 1, 1,
1, 0, 1. Yeah, 1, 0, 1. And you can see that if you add 0 plus 1, you get 1. If you add 1 plus 1, you get 0 and 1 in the carry in. And here you have 0, 0 and 1 was there. That's why you have 1. Do you understand it? Yeah. So, and now we need to make computer calculate it. Yeah, we need to make a computer calculate what we can send to the computer. We can send them numbers in binary format. Yeah, so we can send 0, 1, 0 and 0, 1, 1 in the binary format to the computer. Do you agree? Yeah, and then we need to understand how to put them together. But first of all, let us learn how to create the things that we can add 2 bits, only 2 bits together. So 1 bit and another bit. Because here are 3 bits we are adding. Remember, here are 3 bits we are adding. But we will add now, let us add 2 bits. So let us add 2 bits. So we add 2 bits, 1 bit plus another bit. And what we can receive, we can try to understand. So in the first bit, what options we can have? We can have 0, right? And in the second bit, we can have 0. This is one option. what we will receive if we add this like this, we will receive 0 at the end, right? But what we will receive if we add 1, 0 plus 1, what we will receive? 1. If we put 1 plus 0, what we will receive? 1. But if we put 1 plus 1, what will we receive? We will receive 1 0, but we will have only one bit, so we will receive 0 and the carry out is 1. Yeah, but here it means that you can receive here, and now we have to think about what can be the carry ins can also be carry in. Yes, because we have to have also carry in, because sometimes we can receive 2 bits. For example, here are 2 zeros, but the carry in was 1, and then we had to take it into account. So basically we have to know that as well. And we need to make a scheme. How can we make it? Yes, so how can we do it? So firstly of all, we need to understand how to add 2 bits. So how to add 2 bits. And let us now try to create a simple table, what we can do. So first of all, we can have like this, we can have bit A, bit B, so we add from A and B, yes, so, and then what else we can have? Carry in, yes, we can also. Do you understand what is carry in? So it is carry in, it is something that we can remember from the previous register. And now, then what we will receive? The result, and then also carry out, yes? Understand? Now let us try to make the table for that. So first of all, we can receive 0 here, 0 here. Okay, here could be 0. I will make it like this, so I will copy that afterwards. Here the result could be 0. This one could be 0, and cout will be 0, of course, yeah? But now we will create different options. Now, what happens if we have here 1? Then the result will be 1, right? But now we can have this is 1, then the result is also 1, right? And carry in. Now, if we have here 1 and here 1, then carry in is 0, but here the result will be how much? 0, but carry out will be 1. Do you agree? Yeah, now what else we can have? Here we have 0, 0, but we can have carry in as 1. Then what we will have? Here we will have 1, and this one will be 0. Then we can have 0 and 1, and carry in is 1. Then what we will have? We have 0, and here carry out will be 1, right? Then if we have 1 and 0, and carry out is 1, carry in is 1, then here we will have 0, and carry out will be 1. And if we have 1, oh, sorry. Okay, so here if we have 1 and 1, and carry out is 1, then here we will have the result is 1, and carry out is 1. But here these ones do not have, because totally we can have 8 different combinations. Understandable? Yeah, so now we have to understand how to create this structure, because this is how we can add 2 bits. If we manage to do that on how to say, on our logic simulator, then we can build a small processor which can count together 2 bits. We can just set them two different, if you have a current, if you don't have a current, and then later you will understand that what is the result. Now let us try to open in Moodle. I have given you one also link, which is ALU bit other. Let us open this link. And here there is a tutorial how we can build it through the logic gates. you know that this one is the multiplexer, and here you have 32-bit adder because we have long numbers. But here we have different this logical gates. You see AND, OR, XOR, and NOT. We can see them how they are looking here. But if we scroll down, then we can see here is full adder. So how to add two things. And here is the table which we just drew. Remember this carry in, carry out. So here if I make it larger, then you can see that this is basically the table which I drew with you using this notepad. So it's a little bit written in different form, but it is totally the same. You can see that. You can compare it. 0, 0, 0 makes the same. 0, 0, 1 makes 1, 0. So you can see this is totally the same. Only the order of these lines are different. Do you see that? Yeah, guys? And now look what we can do. We can create the scheme. You can see this is the scheme. How you can add two bits. Look, this is what? This is one logic gate. This is another logic gate. This is another logic gate. This is one more logic gate. This is one more logic gate. And they are all joined together. So now I want you to make this scheme in your logic gate simulator. So here you can remove those guys. So you have empty place. And I want you to make exactly the same scheme. Yes, so please use your tools and try to make the same scheme. So here will be A, it is input, so it will be like toggle, yes. Here will be toggle switch. This will also be toggle switch. This will be the lamp. This will be the lamp, yeah. And here, these are logic gate simulator. Please make it like yourself, yeah, and using that. I will leave it for now and make it, draw it in your logic gate simulator. You see, now we have to build this structure. So if you want to build it, then we need to go to this circuit, and then we need carry in, we need carry A and B, and we need result, and we need a carry out. So I can just rotate and rotate. So it will be carry out. So now remember there was one XOR gate which you need to put here, and you needed one more XOR gate, and here you need to put one thing from here, one thing from here, and you can go to this one. So, and then it were two AND gates. So it was like one AND gate and another AND gate. And there was also OR gate. And then you needed to connect those OR gates here. You needed to connect this thing here. And here you just take for that one and this one. And here you get, I think from that one you get, and from this one. And here this is one like this. And now you can try to select it. So if you have one bit, it will be the result 1. If you have 1 bit, you have result 1. If you have 2 bits, you have carry out, but this is 0. All is correct. If you have no of them, so none of them is there. So if you have 1 carry in, result is already 1. If you add 1 bit, then carry out will be 1, here will be 0. If this one is that, so it is the same. And if you put all of them, that all of them that shine, so you have result and carry out as one. It is like how you add 2 bits. And now imagine that you have to add these 2 numbers. Remember, it was number 2 plus 3. So in order to add 2 numbers, you can have, it was 0, 1, 0 plus 0, 1, 1, and you receive 1, 0, 1. So how to receive this? Then we need to make, how to say, 3 of such things, because this is for 1 bit. Then I need to copy that stuff, so I will make it a little bit more or less together, because otherwise it will be very... So I will put it carry in here. This one goes here, this one goes here. The result is here. Maybe I will just rotate it like that. And this one goes here, this one goes here. This one goes here. I will rotate it like, no, I will rotate it. Okay, let it be like this. And here is the lamp, which is carry out. So this is the carry out. So this is result. This is the carry out. And I will put it maybe like that, so that we know that this is carry out. And this is, maybe I will put it like that, so we know that this is carry in. So, but like that. Okay, now what we are going to do, we need to copy that all. Oh, sorry. We need to copy this all, and let us put, so I will deselect it, and now I will copy this, and I will add it, and I will just put it here. And you see what happens now. This is carry out. I will delete the carry out. I will delete the carry in, and I will have to I have to delete this carry in, and I need to connect this guy here to carry in, this one and this one. So this is connected. Do you understand it? So now I have 2 bits, and now I can again copy that, put it here, and again I need to delete this lamp and delete this guy, and then I need to make it here and here, because it was carry in, carry out. And now I have 2 bits. You can see I have 3 bits. This. And look what I did. I calculate this 0, 1, 0, 1, 0, 0. So I need to decide which bit is first, which bit is second, which bit is third. So this is A, 0, 1, 0. So here I have 0, 1, and 0. Yes? And the next one, B, is 0, 1, 1. So here I have 0, 1, and 1. And look what we have here. So here we have, yeah, but I need to put them differently, because it is like the first one is this one, this bit, 1 and 0. So here we need to put 1 and 0, here 1 and 0. Then the next bit, it is 1 and 1. So here you put 1 and 1. And the next bits are 0 and 0. And you can see that 0 and 0. And finally, you have the result 1, 0, 1. You can see? So, and you have to read it from that place. So you have the result 1, 0, 1. Do you understand it, guys? This is how you can understand that this is 5.
I have a question in table.
Yes.
Open the slide.
Which one?
On this one.
Okay.
So in the 5th line, there is carry in.
In the 5th line here, yeah, carry in is 1, yes.
Yes. When we add that, and the result is 1, and C out is 0. So how in the next line C in is 1?
In the next line?
Yes.
But this is independent. It is like you have carry in 1, A is 0, B is 1. So you put 0 plus 1 is 1, 1 is a carry in, so 1 plus 1 is 1, 0. So result is 0, and carry out is 1.
My question is this, that we get the scene by adding 2. Can I count?
Yes, you can come. Yeah. So let us Let us write logic gate and picture. So you see, these are the logical gates, but what is inside? So transistors. So this is like logical gate using transistors, and here you can see how many transistors if you want to make a logical gate, then here you can see how the transistor acts. So this is a small transistor, and if you want to make logical gates, then you can have the transistors. You can see you put here two transistors, and here you have out, and this is the AND gate. So basically what you need to do, you just need to add one transistor, another transistor, and you get the output. Do you understand? Here you have some kind of current, yes. So and here you can see how it is done. So basically you can use them using Arduino, and you can see the input basically there. But if you want to build an OR gate, this is how you can build an OR gate. If you want to make an ANOT gate, you make it like this. You can see the transistor, and here you have the output, and here you can see what you basically have. It is very interesting how you create it. So if you have a current here, this means you have some resistance. Yes, so you have some resistance, and if you have a current here, here is all the time the current. So if you put the current and current, it will be negotiating this current. They will meet together, and you basically will not receive anything. But if you don't have the current here, this current will make this possible to go. Do you understand? So this is how you make a NOT gate. NAND gate, it is another case. And basically, you need only transistors. Yeah? Do you know what is a transistor? You have seen it. It is like a thing like that, yeah. But transistor can be of different sizes. And if we speak about what is the processor itself contains transistors, and these transistors are very small. And these transistors are so small that the amount of the no so the scale of this of one transistor is several nanometers. What is several nanometers? Nanometer, it is one divided by 10 with the 9 zeros. It is very small amount. You can even, it's nanotechnology basically. And it means that on one single cubic centimeter you can have billions and zillions of these transistors. So it means that, but how many transistors do we need to add two bits? If we come here, we can see this is one gate, another gate, another gate, another gate, another gate. So basically you have 1, 2, 3, 4, 5 gates for having two transistors, each of them. So at least 10 transistors you need for one bit of adding. Do you understand? Then you will need two more transistors, etc. You will have a lot of different transistors to add two bits. But what is to add two bits? Your number, for example, if you want to add number 35 plus 45, it is very long. It can contain 32-bit long. Yes, so this, and then you have to have 32-bit adder. So you have to have, for one bit, you have to have 32 such things in one row. Then you can submit two numbers to be added. But you can simultaneously add one number, another, and then you can multiply, etc. And all the time you need those transistors. And you just need the transistors, and then you need a current to go through transistors, and the transistors show you the logic gates, where the current goes and where the current doesn't go. So basically you receive results by giving here some currents. If you send the details, so like if you send the signal with that, you can get here is current, here is current, here is, here no, here no, here no, and then you get the result, and that's all. So this is how the processor works. Is it understandable? And if you want to see that more, so this is like how it works. Online guys, is it understandable more or less?
Yep.
Yes, sir.
Yeah, okay, very good. Okay, okay. Now let us see the thing. So here, this is the full adder scheme, and this is how this one is added. So now we can have a look into one more simulator how the but I think we did it. So now, yeah, so this is enough for today, I think, for these transistors. Here you can also see, for instance, this fact. So here is 32-bit adder, and you can get here, for example, now instead of lamps, let us move here. Let us try to understand how this works. I will put here 4 different switches, and we can see how it works. You can see here is the 0. So I will put like this one here, this one here, uh, this one here, and this one here. And now I can put, you see, 0. Here, if I put this one, it is 1. So it means that this is the lowest bit. The lowest bit, it is this. This one is the, if I want to have 5, I need to have 1, 0, 1. Remember, like that. So this is 5. And remember, where was the lowest bit? The lowest bit was here. So you can connect not this toggle switch to this part, but you can connect that thing to that part. So you can connect it to lower bit. Then this part can be connected to this part. So here, I need to delete it. And I need to make it here. And this part is for the next bit. So this is like this here, and I connect it to this. You see, now we have 5. Do you see that? Now we can try to see how we can add. You see, it was I have here 1 0 0 and 0 1 1, and you start from the lowest bit. Now let us try to put 3 plus 4, and we will try to get 7. So let us try to put 3 plus 4. How we make it 3 plus 4? Let us make 3 plus 4. So we need to create 3 plus 4. 3 plus 4. What do we have here, guys? We have to have 7. But in binary notation, what is 3? It is 0, 1, and 1. So if we take this one is 0, 1, and 1, so we will make both of them zeros. So let us make 0, 1, 1. How do we make it 0, 1, 1? So it is 3. Where is the lowest bit? This is the lowest bit. So this is 1, 1, and 0. So we have 3, you see? Now we have to add 4. What is 4? Is 1, 0, 0, right? So what do we need to have? Here will be 0, right? Here will be 0, and here will be 1. You see, we get 7. Very nice, yeah? So this is how it works. So then and you see 1, 1, 1, we get 7. Yeah, so we can delete this one. So what else we can have? Can we have 8? Can we have 8? Okay, let us try to get 8. How can we get 8? It is 3 plus 5. 3 plus 5. Let us try to get 8. So what is 3? It is 0, 1, 1. What is 5? It is 1, 0, 0, right? No, 1, 0, 1. Okay, yeah, let us try to make it. So here 0, 1, 1 is the same, but here we have 1, 0, 1. So here should be 1, 0, and 1. But we have 0 here. What happens? Why we have 0, guys? Why we don't have 8? Who can explain me?
Because we have used 3 bits.
Yes. And you see, what is 8? Look, guys, what is 8? 7. 7. You can see 7. 7. 7. It is 1, 1, 1. But what is 8? What is 8? Can you represent me in the binary form? 1 0 0 0. How many bits shall we have? 4 bits. And you can see that we get 0. Why? Because we forgot to enter this last bit. But last bit is here, you see? And this is carry in. And we can put this carry in. We can put this carry into this last bit. And then we will have 8. Do you see that? And now we can try to figure out the next thing. How can we get 9? 3 plus 6. Yeah? What is 6? 3 is equal to 0, 1, 1. What is 6? 1, 0, 0. Yeah? This one? Are you sure? No, I think it is 1, 1, 0. Please double check. 1, 1, 0, yeah. And now let us have a look. 1, 0, 1, 1 is the 3. And how here? 1, 1, and 0. Yeah, we have 9, you see? Very good. And we can get 9 by using 4 plus 5. Yeah, let's make 4 plus 5. How can we make 4 plus 5? Let us take 4. So how can we make 4? This is first bit of this is the first bit of 4. This is the second bit of 4. This is the last bit of 4. Yeah. So 4 is what? 0, 1, 1. So here should be 1. Here should be 1, and here is 0. No, this is 3. So 4 basically it is 1, 0, 0. It is this 4. You see? This is 4. And now how to make 5? It is 1, 0, 1. And you see you have 9. Yeah? So this is how it works. Do you understand? But we are limited to how many numbers? How many numbers we can use here? Only we can actually calculate until 15, because 15 will be f. We will have here f, which is hexadecimal format. And if we want to have more, what shall we do? What is it? We need to add more these bits, yes? And this is why we need to add more bits. And usually in computer architecture, you use 32 bits, 64 bits, etc. But if you speak about numbers, you need to know what you write in your programs. For example, you can Google, which is your favorite programming language? Python. Okay. Python, so integer type. Let us say what is integer type in Python. And Python numbers, we can see the integer type. This is the Python. And now we can have the range. We can find the Python integer type range. Let us try to see what is this. And you can see that in Python, if you use integer type, it means that you can use numbers from this amount to this amount. And let us calculate how many bits we can see. And you see we have int 32. You see that? So it means that we have 32 bits for decoding integer numbers. And when we speak about 32 bits, then inside the processor, there shall be a block which can handle operation of 32-bit adding together. So inside the processor, there should be at least one block which will look something like this, only here will be 32 of these adders, yeah? And then you will have to enter here especially one number and another number, and it will give you the result. Understandable? Yeah, okay. And pay attention that these logic gates consist of what? What is the basic element of the logic gate? Who remembers that it is like, what is this physical element from which we construct logic gates? How do we? Transistors, yeah, this is transistor. So transistor is one special device which we use in processor, and it builds logical gates. That's why in the processor we speak about the number of transistors, because we have mostly in the processor there are transistors. And let us look what is a transistor. What is a transistor in the processor? So here we can have pictures, and you can see these are transistors inside the processor, which look like that. But it is you can see this is the these are the small transistors for a very primitive processor, 8-byte RAM. It was long time ago. It is like a lot of transistors are being there. But now you see this transistor is big. But now, do you know what is the size of each transistor? It can be 2 nanometers, 7 nanometers, 12 nanometers. We can have a look into, there is a special program which is called CPU-Z, you know? You can download this program, which is called CPU-Z, and you can see, you know about this program before, yeah? So let us download it, and it is Chinese program, but it gives you information about your CPU. So if you just unzip it, and I will launch it, okay? So here you can see that software, and I don't know if you can see it very well, but I will like to handle it larger, so I will try to open magnifier I have, yeah. So here we can have, oh, that's much better. Now you can see that, yeah. So you can see that I can read the data from my processor. It is Intel, and you see the technology, it's 14 nanometers. It means that your transistor can be up to 14 nanometers small. Yeah. Can you imagine what is 14 nanometers? It is 1,000 times smaller than your hair. If you take your hair, it is several microns. But micron contains 1 micron is 1,000 nanometers. So it is like if you divide this hair into 1,000 pieces, this will be one piece will be 1 nanometer. Can you imagine how people do these transistors? There are lasers involved, and I advise you, when you have time to drink your coffee at home or tea in the evening, Google in YouTube how processors are made, and you will see the whole technology. In YouTube, there are plenty of videos, and you will see that in order to produce a processor, you need to grow the crystal of silicon. Then you need to cut it into pieces, and you have several layers, and then you will have to use lasers to cut special things to have the laser pattern, and then you add some acid there to create some kind of special, like I say, gravings there, and then you put another kind of substance, and then you create the transistors. It is so nice technology, but it's very hard to make it. It takes it is very expensive technology. That's why processors are very expensive. And at the moment, I can tell you that the best processor has 2 nanometers. 2 nanometers, yeah. And it is possible to be made only in Intel or AMD technologies, which are under license of the US, and other countries cannot do that. And there are only several factories which can do that. In other factories, there are some kind of other, usually it's 28 nanometers, it is easy to make. but 14 nanometers, it is already good result. 5 nanometers. You can use your CPU Z in your computer, and some of you have your own PC. You can give me information what kind of lithography you have. You can check whether you have less than 14 or more than 14. You can see that here. And meanwhile, if we speak about the processor, we can have this program. Maybe we can see what kind of these things we can know here. You know the name, the code name is okay. Here is the specification, the model, and so on. Instructions. Here is very nice thing. Instructions which processor understands, because these instructions are coming from old times. For example, MMX instruction was even in 90s. There was Pentium MMX. It was very expensive computer in the end of 90s, and you can use this technology. It is especially connected with some graphics, etc. So, but still we are using that. Yes. So, and then this technology, and each time we produce a new processor, can new instruction appear, and then you have to keep with them. And here you can see the core speed. How many cores are in this computer? How do you think? How many cores are here? Can you? 8. You can see that it's clear here. And this is threads. This is like to and fro. You can go from each core that has 2 threads. Well, do you know what is a cache? What is cache? Do you know what is that? You know, guys, for example, I can explain you in very primitive words. Remember, we did this logical simulator, and we had 2 numbers to be close together. When we received this number, we need to keep it somewhere. We need to store it somewhere. Where do we store it? Inside the processor memory, and this is the cache. Yes, so and then in the cache we can also bring some values from the hard disk and from the operating memory in order to, from random access memory, in order to work with them. So cache is necessary to keep all the data. Yeah, and the better, the more expensive the computer is, the more cache it has also, because the memory is very expensive. Here you can see also about the motherboard. You see, this motherboard is produced in 2020. You see, guys, have you checked your lithography in your computers? What was the nanometers? Huh? Haven't checked? Please check. You have two, at least some of you have your own PCs. You can check what is the nanometers there. And here you can see 16 GBs of RAM. And you see here you have 2 slots. You can see what kind of graphics you have. Here we have NVIDIA. This is good for 4 gigabytes of NVIDIA memory. So these computers are quite okay. And here you can have a benchmark, etc. So it's understandable, yeah? Yeah, please. So what we have a flip-flops for? So if you Google what is a flip-flop, it is a special kind of thing which we need to, how to say, here in the, I can add a flip-flop. You can see here we have one flip-flop, another here. If I add one flip-flop here, if I double-click, I can get something like this. So I have 2 of them. And here, flip-flops are used inside memory. So it's like how the memory is done. And here you can see, if I switch one of that, and I want to remember it, I have to make this. And you see, it remembers. Now, if I switch it off, it still remembers that. But if I do it like that, it still remembers that because you don't have. Do you understand? If you want to switch this position now, you see I do this, and it switches to that. So it remembers another state. And you can use some other, you can see this one, and now if you do like that, it will remember the state where 2 of them are. But it is sometimes blinking, but it has 2 of them are still having the same state. Do you understand that? And if you want to check to remember this state, you need chick chick, and you remember that state. So this is how your memory works in your random access memory. You have the flip-flops, yeah, and you see the flip-flops again. What do they have? They have only logical gates. So again, you have transistors. You understand? And that's why computers require transistors. And no way, nothing more, only transistors. So you have transistors, current, and that's all. And this is basically all the hardware. Yeah, computer hardware, it is like memory, processor, it is transistors. You just take it, and transistors, diodes, sometimes you have to have capacitors because it's like condensing the and the, not requiring the overload, etc. So this is how it goes.
What is flip-flop?
Flip-flop is the special kind of how to say latches. They give you an. This is a flip-flop. This, and there are several types of flip-flops. There are SR flip-flops, GK flip-flops, D flip-flops, and T flip-flops. And you can take one of them and understand what is there. Okay, so I have like a homework for you for these exercises. So what you need to do, I will give you here a homework. Just Google about different types of flip-flops and record a small video where you explain where these flip-flops are used and what they are used for. Okay? This is will be a good training just to just make it for the year, and that we will finish this topic again. Okay? So I will put here the flip-flops here, assignment flops. Yeah, you have to choose. Please choose one type of flip-flops and record a small video. Video explaining how it works and and where it is used. Where it is used. Yeah. So this is like simple one. You can just try to do that. And, yeah, you can use it. Okay. Okay, guys. So I can think we can finish a little bit earlier today. Yeah. And thank you for what you came to the classes. Yeah, and it's nice to that you came exactly not online but offline. For those students who are online, okay, if you cannot come, it's okay. We can also work online. But you are welcome also. The next week I will be also in the class. Yeah, and see you next week. Please try to make those videos, and we will see each other next week.